Let me introduce myself. My name is Simon Conway Morris, and I'm now retired, but have been a paleontologist and I suppose evolutionary biologist in the University of Cambridge, and here specifically in the Department of Earth Sciences for many years. And if I may, I'll give a tiny bit of autobiography, which is not especially interesting, I suppose, but I've been all too keen on fossils since I was probably about the age of 8. And first thing I'll do is show you my very first fossil I collected. And we'll probably need to look at it in a little bit more detail. This is, and those of you who know about fossils will recognise it instantly, it's flint, it's a sea urchin, it's actually a Cretaceous form called Micraster. And where does it come from? It comes from Rains Park in London. And in fact, it's from old gravels. And the day I discovered it, I was just berserk with excitement. Things have sobered up since then, but that was, if you like, the starting of the ignition. So since then, there have been a whole lot of lucky breaks, and I came to Cambridge many years ago to pursue a PhD with Harry Whittington. And this is on a very famous deposit called the Burgess Shale. And here perhaps is the first echo of the Etches collection as well, because the Burgess Shale is much older than the Kimmeridgian, which Steve Etches has excavated so brilliantly. It's Cambrian in age, but it's absolutely extraordinary because the fossils there are superbly preserved. They are, in many cases, complete with soft parts. And once again, I'll show you a specimen. And when people see fossils like this, they are generally pretty unimpressed because they are really not obviously visible. And this particular specimen I have in my hand at the moment is actually not on a group I worked on. It's an arthropod. But the point about the Burgess Shale is this really triggered a whole set of evolutionary debates as to the nature of the fossil record and whether, for example, evolution has any sort of directionality. And we'll come back to that in due course. Now, at one point in my career, I thought I would become very interested in special preservation. That is, where you have exceptional sedimentary conditions which allow the sorts of things which include soft parts. And once again, if we go to the Etches collection, we'll see such examples of a fossil squid. And correspondingly, although a very, very different lithology, this sort of fossil here is actually from the Zonenhofen limestone in southern Germany. It's a very different lithology to the Kimmeridge clay. It's a limestone deposited near to coral and algal reefs, and this is a fossil squid. And I thought at one stage I might research in some detail how this exceptional preservation came about. But for better or worse, I didn't. I became more and more diverted into various more general questions to do with the nature of evolution. Now, I should say at this stage in particular that I've known Steve Etches for quite a few years. We know the village of Kimmeridge quite well as well. We always feel very welcome there. And it is, of course, one of the most beautiful parts of England. And Steve himself has opened a completely new set of windows into the nature of the fossil record. And the great advantage of his collection is it's just this time slice, which may be very narrow, but gives you this insight into the diversity of life at that time. And we're right at the end of the Jurassic. Now, where does that lead into my sort of interest? Because in point of fact, nearly all my work has been on substantially older fossils, a little bit from the Carboniferous, but principally from the Cambrian, partly Burgess Shale, a great deal of work fairly recently in China, also Greenland and places like that. And here, if I may, I engage in a piece of shameless and unadulterated self-advertisement, and I draw respectfully to your attention this recently published book. And as you should be able to read, it has the encouraging title From Extraterrestrials to Animal Minds, but beneath that, perhaps less easy to read, is the suggestion that these are myths of evolution. And what I want to do today is in a way reflect or echo Steve's sort of work, because in these myths of evolution there are areas which are a little bit far removed from paleontology, and I won't go into any particular details. One of them, for instance, is that my view in terms of evolutionary process is that something like a human is very, very likely to evolve, and this is because there is a phenomenon known as convergent evolution, whereby the same sort of solution keeps on reappearing. And if you think about humans, then indeed there are a whole set of things which we possess, which not only do we share with our other animals because of common descent, but if, for example, you look at the eye of an octopus and you look at our eye, we know the common ancestor did not have such a complex so-called camera eye. It's a wonderful example of convergence. And in principle, because we now know that out there are billions of Earth-like planets, then the likelihood should be that there are indeed human-like species there, some of whom will evolve a technology and eventually decide to go to other parts of the galaxy. And yet there don't seem to be any extraterrestrials at all. And again, it would be a different talk, and I could unpack that as best I could, because it's a fascinating conundrum. After all, there's so much time, so much space, but seemingly no signals at all, no visits, nothing. What's going on? And in a different sort of way, with regard to the inevitability of something like a human evolving on any Earth-like planet sooner or later. Despite all that, when we look at the animals around us, they are intelligent, they learn, they have memory. Some of them even use primitive tools. But my view is, in fact, the gulf between humans and other animals is basically unbridgeable. Here we are talking through a very complex technology, but we're using speech. Animals do not have speech. And once again, these are the sort of topics which that book is concerned with. But in the context of paleontology, there are two aspects I want to talk about very briefly, and they are to do with the so-called myth of mass extinctions, and the second myth is the myth of missing links. And you know, if you're in any way a scientist and you're saying, what on earth is this character talking about? Come on, get a grip, dear boy. He doesn't believe in mass extinctions. He doesn't believe in missing links. No, it's not like that at all. By myth, in this particular context, I mean areas of received wisdom where everybody, whenever you mention mass extinction, everybody nods and says, oh, yes, yes, that's right, that's right. And when you mention missing links, everybody says, yes, yes, that's absolutely right. So am I saying that mass extinctions are fictions? No, very much the reverse, in point of fact. Mass extinctions, of course they happen. But the key view of mass extinctions is that they reset the agenda of ecology and evolution. Basically because they are so severe that the likelihood of any particular group of animals or plants surviving, what we call a clade, is really a matter of chance. And so it's a bunch of lucky survivors which go through the mass extinction. The planet is devastated, mostly because of volcanic activity in the case of the end of the Cretaceous. In addition, an impact probably from an asteroid, maybe a comet, it doesn't really matter. But it's bad news all round. And so the notion is that the evolutionary agendas are radically reset, and that confers an unpredictability to evolution. It could have gone one way, it went another way. And correspondingly, despite what I mentioned a moment ago about the inevitability, as I have suggested, of something like a human evolving, from the perspective of planet Earth, 66 million years ago, when the asteroid ploughed into an area in Mexico, the dinosaurs went extinct, the mammals seized the opportunity, and amongst those mammals, ultimately we find the primates, and from the primates, then the apes, and then ultimately ourselves. But if that mass extinction had not happened, if the asteroid had just missed, which is perfectly possible because asteroids swing past this planet every few months, and only very rarely do they actually land, which is just as well. So the view is that the world is trashed, the survivors emerge blinking, there are a lucky few, and they repopulate the planet in unexpected directions. Well, that's only true to a point. And the point about mass extinctions is, I would suggest, paradoxically, they're actually creative. They're not destructive. They're destructive on the day, of course, because it's bad news if you're in Mexico 66 million years ago. But on the other hand, we need to take a slightly wider perspective. Because in the case, so far as I'm aware of all the mass extinctions, the people who survive are the sorts of groups which are going to take over the world sooner or later, come what may. So if we look at the case of the Cretaceous, which is the period just after the Cambrian, where Steve Etches has been working. So we go from the Jurassic into the Cretaceous. There are lots and lots of dinosaurs, and there are flying reptiles and all the rest of it. But there are also birds, and the birds are already evolving pretty rapidly. And in point of fact, that squid I showed you from Zolenhofen also houses one of the first birds, an animal called Archaeopteryx. And when I go down to Kimmeridge each year, I say to Steve, have you found a fossil bird yet? And he says, as far as I know, not yet, but he will, I'm sure. Those birds are rapidly evolving, and interesting enough, there is a suggestion that they are now coming into competition with the flying reptiles, the pterosaurs. And one possibility is actually the birds are taking over the small size niche. And it's striking that in the Cretaceous, the flying pterosaurs get bigger and bigger and bigger. They end up the size of gliders. They're huge. And there is a suggestion, in a sense, they are being displaced into this episode of gigantism. So the birds are already tweeting away in the forests. What about the mammals? That's us. Well, in the case of the mammals, what we see is that already they too are beginning to diversify with the dinosaurs. It's a fiction to think that every Cretaceous mammal was the size of a shrew eating insects. Already by that stage, some groups of mammals, they're relatively primitive, but they are themselves about the size of a dog, and they're eating dinosaurs, baby dinosaurs. There's also another fascinating line of evidence, which is slightly indirect, but that is there are various trackways which are clearly made by mammals. And these trackways are evidently made by surprisingly large mammals, once again in the Cretaceous. And the point is that here in the Cretaceous, the mammals are already beginning to diversify. The major groups are beginning to establish themselves. They've got a long way to go. And then what happens? Kapow, yes, there's a mass extinction. And the dinosaurs go extinct. But let's go to a counterfactual world whereby there is no mass extinction for one reason or another. And the dinosaurs continue, of course. But then what happens is as we move into what we call the tertiary, and especially towards the Oligocene, maybe 40 million years ago, the planet begins to refrigerate. It's linked to levels of carbon dioxide, nothing to do with humans or anything like that. And as the world becomes cooler, so the temperate and near polar zones are not the sort of places where reptiles are going to be found in large numbers. But warm-blooded mammals, and indeed warm-blooded birds, are going to do absolutely fine. Mammals and birds have bigger brains. In the case of the mammals, some of them are dexterous, and we know that independently they've evolved tool use. My thesis would be that sooner or later, the dinosaurs would be driven towards extinction. In fact, when an intelligent biped emerges, roughly 50 million years behind schedule, it will do one of two things with dinosaurs. It will either put them into game parks, or they will end up in high-end restaurants. So it takes longer, but because the mammals have inherent capacity to do the sort of things which the reptiles never can, ultimately they will inherit the world. So the crucial thing about mass extinctions, I would suggest, is in fact that, as mentioned, they're creative. They actually accelerate a process which is going to happen in any case. On the day, as already mentioned, very bad news indeed. And there's one other small aspect about this which I find very interesting, and that is, of course, that although mass extinctions are important, undoubtedly, partly because of the acceleration, if you like, the world itself in the Cretaceous is already busy modernising. So yes, there are dinosaurs everywhere and giant pterosaurs and all that sort of excitement, but with regard to the rest of the planet, what's happening there? Well, amongst the most obvious is the development of the flowering plants. And they engender a whole set of additional evolutionary circumstances, especially in terms of the evolution of the insects. And by the end of the Cretaceous, for example, we have rainforests. So this modernization of the world is well underway. So once again, there are long-term, deep-seated trends which are leading the world towards its modern configuration. So that's one of the evolutionary myths, and I'm not sure this is necessarily that controversial, but on the other hand, I would humbly suggest that it is a rather different perspective on these, rather than emphasis on mayhem, destruction, chaos, chance events in evolution. In point of fact, they are integral to a planet. You can't avoid mass extinctions. Mass volcanism is going to happen periodically. And if you look at any of the other ones, especially the one at the end of the Permian, about 250 million years ago, very much the same story emerges. Many of the players are already in position, and although it's disastrous at the time, more disastrous than the end Cretaceous extinction, most likely, even so, the recovery is rapid, and the animals and plants which are going to inherit that world are already in pole position. What about the second myth I want to talk about very briefly, the myth of missing links? Now, missing links is a sort of Darwinian trope, as we would say. It's the sort of thing which appears in the newspapers, and nothing wrong with that, because it's, if you like, a sensation. And at the time when Darwin was first establishing the theory of evolution through natural selection, he realised that a crucial part of the evidence had to come from the fossil record, because of course it gives us a dimension of time. And if indeed you can see how the transformation of a group which, if you look at their ancestor, looks utterly different, then by exploring the steps in the fossil record, you can see that something which looks at first sight incredible, in point of fact, is achieved in a slightly unsurprising and unremarkable way. So in what sense are missing links a myth? Well, my thesis here is not that they're a myth in the sense that they don't exist. Of course they do, because we have evolutionary continuity in all cases. That, again, is what Darwin established from many lines of evidence. It is more particularly that, if I give a couple of examples very briefly, if we look at the invasion of land by the group of fish which amongst their modern day aquatic forms include the lungfish and the coelacanth, then we have a spectacular story of the acquisition of limbs, changes in the head, changes in many aspects of physiology, including breathing and so forth, which enabled a once completely aquatic creature to become ultimately fully terrestrial via, if you like, an amphibious stage. And much of this happened in the Devonian, and indeed here in Cambridge there was, she's died now unfortunately, Jenny Clack, and corresponding in the United States, Neil Shubin in Chicago, have done wonderful work documenting the fossil record to show how this transformation of a fin into a leg was achieved. And this is great. But what is slightly less remarked is that if we look at the evolution within this group of fish, if you really want to know their name, they're so-called Sarcopterygians, then it turns out in fact that independently several groups of Sarcopterygian fish were moving in very much the same direction. They were different offshoots of this tendency to transform a fin into a leg, but they are more or less independent. So the point about this is that by the time you start with a fish which has got rather prominent limbs and particular arrangement of the bones there, the development of a leg is effectively an inevitability. It's going to happen whether you like it or not. Land will be invaded by some sort of fish. So what I mean by the myth of missing links is that, of course, there are missing links, but there are a whole set of these missing links. And if one particular evolutionary adventure is frustrated for one reason or another, you don't have to worry. Somebody else will come along pretty shortly and end up doing much the same thing. And I'll conclude, if I may, with another such example, which I think is even better documented. And I mentioned in passing a little bit earlier the bird Archaeopteryx from the Solenhofen limestone. Now we know that the birds are effectively dinosaurs, and I'm not a vertebrate paleontologist, but I have on authority that they come or belong to the group known as the theropod dinosaurs, which are bipedal dinosaurs pretty much. So they're already on two legs. We know various other things about them. Of course, their forearms are free, and they also have a tendency to develop various sorts of covering on their body which are more than scales, and these turn out to be feathers. And because of this superb preservation of many of these early theropod dinosaur birds, we can actually see the various developments in their plumage. And it's quite clear that originally, well, not quite clear, but it seems the case, that these feathers probably evolved originally either for such matters as sexual display, and or insulation, and because they're becoming warm-blooded, to control the body temperature of them. So fine and large. So what do we then see? Well, it's actually a similar story to what we see in terms of the sarcopterygian fish. That is, that it's not just one group of theropod dinosaurs which ultimately takes to the air, mostly as gliders, but almost certainly powered flight was evolving probably, well, it depends who you talk to, 3 times at least, but quite possibly 6 times. And we must remember that the fossil record is incomplete, it's imperfect. And again, to return to Steve Etches' collections, that's why that collection is so important, because it's this extraordinarily sort of breadth of information, you know, as many forms as possible are being found, and new ones are being found every year. But despite all that, when we go to the origin of the birds, we find that several things happen more or less concurrently, and one of them is that these animals, not surprisingly, sometimes, not always, become quite small. They're also developing hollow bones for various reasons, so they're becoming quite light. Their forearms are free, and in many cases they have feathers, but also, of course, they very often have feathers on their legs as well. And so here we have something which effectively, to use one term, is pre-adapted for flight. So it's not really surprising that when we look at the evolutionary relationships amongst the so-called para-avians, amongst these theropod dinosaurs which are going towards the birds, that independently, as mentioned a number of times, and whether they achieved this by falling out of trees or running faster and faster or some other mechanism, they actually took to the air. And once that happened, then, as I mentioned a little bit beforehand, once they began to expand, and again the story is very complicated because the truly modern birds only appear right at the end of the Cretaceous, but they're there before the mass extinction. And there are several other very important groups. But collectively, this means that the occupation of the air is an inevitability, and the pterosaurs, which at that time were dominating the air, were then, as mentioned, being driven towards gigantism because of the success of these birds. So the myth of missing links, once again, is not just one heroic group which by hook or crook manages to become airborne, but in point of fact, by the time you have a fairly small theropod, then it's going to learn how to fly. So call it a myth if you like, but it's a rather different way of looking at evolution. One of the delights of being a scientist is that, well, you learn something new every day, but also one finds that areas which at one time absolutely fascinated you, like paleontology, continue to do so, but other areas come into focus a bit more. And you can argue, in fact, you'd have never got to these new investigations without that background. So, for example, when I was working on the Burgess Shale, and indeed at that stage in my PhD and then my postdoctoral time here in Cambridge as a research fellow in one of the colleges, I was very much the opinion that such was the diversity of animal life then, that the rerunning of the tape, as Stephen Jay Gould put it, would have meant that, you know, the outcomes would have been completely different. And as indicated, with regard to aspects such as mass extinctions and the inevitability of humans and all that sort of business, then I think I've changed my mind reasonably dramatically. I'm not worried about that. I'm allowed to change my mind. Scientists must change their mind. But what this has meant is that we have myths like mass extinctions and myths like missing links. But if I may, I'll just talk a little bit about some other interests to do with, first of all, the myth of extraterrestrials. And this is a good example because tomorrow, literally, I might be proved totally and utterly wrong. And that's no bad thing for a scientist to remember. So, no extraterrestrials? Well, there are UFOs and all sorts of things, and indeed there are people who claim to have met aliens and so forth. I'm not going to go into that area. Let's put it under anthropology, for want of a better term. But in terms of the habitability of planets, let's stick to what we presently call the science. It's clear from some very clever investigations by astronomers that probably most suns, stars, have some sort of solar system. And there are various reasons why the technology makes it easier to detect larger planets at the moment, and Earth-like planets, because of various reasons, are much more difficult to detect. But it's clear for many reasons that the number of planets similar to the Earth is staggeringly large, even in this galaxy. And of course, not all of them will be necessarily habitable. Not all of them perhaps have plate tectonics or an atmosphere with oxygen, and so on and so forth. But so enormous is the potential number of Earth-like planets where animals would thrive, that if you agree that the evolution of an intelligent, probably bipedal, dexterous, large-brained, articulate species is not completely out of the question, then such a species will begin to want to explore beyond its local solar system sooner or later. And we then go to something which is well known in terms of astronomy, and it's called the Fermi paradox. And Enrico Fermi was a very distinguished Italian physicist. He fled Mussolini's fascist Italy with his wife, who was Jewish. They went to the United States, and he was involved with the Manhattan Project and the building of the first atomic bombs. He's a very brilliant man, and sometime after the Second World War, he's sitting with some friends, all of whom are frighteningly intelligent, and he just says, this is in Los Alamos, New Mexico, he says, where are they? And in point of fact, that question wasn't quite as we now read it, but in essence what we now ask is, why isn't there any evidence of extraterrestrials? And even as a paleontologist, would it be completely impossible to find some evidence of a visit? I mean, you have to know what you're looking for, but it doesn't seem to be completely out of the question. But more significantly, and again, it would take too long to unpack in detail, there is growing suspicion that the attempts to find signals from a remote civilization are destined for failure. It's been referred to as the Great Silence. It's incredibly quiet out there. And there are many, many explanations to this Fermi paradox. But this seems to me an extraordinary paradox of evolution in particular. Where are they? Are they hiding somewhere? Well, yes, all sorts of things are possible. And this takes us far too far away from mainstream science. But my suspicion is, and there are various attempts to explain the Fermi paradox in this context, and without sounding too melodramatic, it is to suggest that actually the universe is not quite as we think it is. And in part, and this will allow me to go to another myth, it is actually, and this is rather sort of either sort of bizarre or strange, and it's to do with the nature of mind, the nature of consciousness, all these good things like this. And one here is dealing with very difficult philosophical waters. But I can't help but feel that the universe which we see, if you like, its materiality, is only a tiny part of the whole of reality, if you like. And you get a sort of hint of this, and I'm not a physicist, but from quantum mechanics and quantum physics, because the behavior of particles at this very small scale is utterly counterintuitive. And as you will probably know, and I'm not a physicist at all, but if you look at light alone, you can say it's working as a particle or it's working as a wave. And you can do experiments, simple experiments, to show the light is a wave and the light is a particle. Both of them are absolutely the sort of things you do in sixth form, if not before. But light is both a particle and a wave. So what's going on? And I'm not saying that this is impossible to understand. Indeed, in terms of the equations, it's all there. But it is this sort of hint that around us there is a degree of uncertainty. And are the extraterrestrials in some way involved? I haven't the foggiest idea, but I wonder if they might be. And I mentioned just a moment ago this myth. And the final myth in this context is to do with animal minds. Because as it happens, we have a dog, and many other people have pets, and there's no doubt that these creatures, I will even include goldfish if you like, perhaps, have emotions. They certainly can learn things, undoubtedly, they can memorize. But when you begin to look a little bit more closely, although clearly we are descendants of a common ancestor with the chimpanzee and the gorilla, separating perhaps 6-7 million years ago, and indeed if you go to a chimpanzee, for example, we find that they vocalize, but they don't have a language. We find that sometimes, especially the females, use large rocks to break open nuts, so they're tool users. But in these two contexts, we can stand back straight away and say, what is it which means that what they are vocalizing cannot count as language? And effectively, with language, we are conveying meanings, whereas the difference to the chimpanzee is that they are effectively demanding things. They're not using words in terms of conveying meaning. And correspondingly, if you look at the tool use, that's fine. But the young chimpanzee will sit beside the mother, but not once will it show the young chimpanzee how to break open the nut. The young will observe, but the process of learning is painstakingly slow, takes several years typically. And even if they do pick up a stone, they're never corrected by the mother. And the point here is that animals don't teach. They'll learn, but they can't teach. And this takes us off into some very strange waters indeed, but there is a suggestion that the animals are not able to enter into each other's minds. And I came across a fascinating example of this very recently, which sounds trivial, but actually tells me, I thought, an enormous amount. And it's largely not exclusively to do with chimpanzees, but also some of the other apes. And people who study these creatures in the jungle will confirm that they live in troops, but they often disperse, and sometimes they're away for quite considerable time. And then when they come back again, they're all greeted, cries of delight. They're all delighted to see each other, kissing, hugging, all the normal stuff, and really human-like in any ways. And they clearly recognise each other, and there's an emotion there. And of course, there's all sorts of other things, including aggression, many other less pleasant things. But do you know something? They never ever say goodbye. Not once. And this is something we take so naturally that it's one of many hints, like their inability to teach, which collectively suggests that for some very mysterious reason, they are unable to join the dots. They're unable to live in somebody else's shoes. And that's why, although an animal can mimic, it, for example, could never be an actor. And one can go on and on in these examples, and it is not, do not misunderstand me, this is not to say animals are in any way inferior or whatever, or that we can mistreat them because they don't have human capacity. Not least because, of course, they can't speak. They can yell, that's for sure, and they can indicate pain, that's beyond dispute. And it would be wrong to do anything which inflicted pain on them, by definition. But when we look at the ability to communicate with animals, another slightly neglected aspect of this is that you have to train them. And that's absolutely fine. And sometimes these animals, usually in laboratories, not always, but they take an awfully long time to train. Now, by awfully long time, what do you think I mean? Maybe 100 trials or 200 trials? Well, if you're lucky, you might. But in cases such as one particular experiment using starlings, as it happened, it was 50,000 trials, 50,000. And there was another case to do with rhesus monkeys, where they wanted to see if they could engage in what's called entrainment, which is effectively that you've got a metronome and you change the pitch of the metronome and you get the rhythm. And it is true that there are animals like cockatoos, which can indeed snowball, it was a famous example. But in this particular case, these experimenters spent the best part of a year to see if these rhesus monkeys could engage with a metronome, and they failed. So that's sort of interesting, but it tells you something much more interesting than that, and it is that what other species would actually spend a year trying to train an animal to do that? Only we would, because we have curiosity, because we have this desire, in a sense, to talk to other animals, to understand what's going on in their minds. And minds they certainly have. But those minds really are, in some very curious way, different to ours. There's a gulf there. There's a scientist in Australia called Thomas Suddendorf, and he wrote a book some years ago called The Gap. And in essence, he is saying again and again, look, chimpanzees can do this, they can do that, or parrots can do this or that, or New Caledonian crows can do this and that. They're tool makers, for example. And yet they just do not join the dots. And again, this is not to be destructive. And let me conclude, if I might, with just one, I think, very telling example, which goes back to, and this is a famous one in terms of animal behavior, about Aesop's fable. So there's a thirsty crow, there's a jug of water, but the water's out of reach. So the crow gets pebbles and drops it into the jug so that the level of water rises. Welcome to Archimedes. And he gets a drink. And in the laboratory, you can do a similar set of experiments whereby you have a test tube with some water in it and a bit of food floating out of reach. And you train the crow to drop the stones in and the water levels, and they get their dinner. Very good, excellent. And that's, all rather impressive because, you think, God, the crow's working it out. Except that then you make the experiments a bit more complicated. You make sure that you can seal, say, a U-tube or several tubes, only some of which are connected. Now, in the case of a 1-year-old child, they probably would remain baffled. But very quickly, children learn that there is cause and effect. The crows do not. They eventually learn, but it's by trial and error. So in other words, they cannot engage in rationality any more than, as they don't have language, they cannot convey meanings. And this sounds again as if I'm trying to be negative about these creatures, and I'm very much the reverse. What astonishes me is, why are we so different? Because all things being equal, there may be many, many advantages in being a human with speech. But, some people might say it's a bit of a mixed blessing. Animals may have warfare of a sort, but it's nothing like the degree of what we call hyper-cooperation, which is essential for a football match, or in a more grim sense, warfare. So it's not an unalloyed success story. But I can't help but feel that this question of what is the gap, the gulf between animal minds and our own minds, has some sort of connection to those absence of the extraterrestrials. That once again, one's trying to ask ourselves, and this is a familiar question to philosophy students, is what is it which actually makes us conscious? And the received wisdom at the moment is it's all in the head, it's all in the brain, and in a certain sense it has to be located within the brain. But why do we know red is red? Why do we know garlic smells like garlic? This question of so-called qualia. And this is a very well explored area, and people have been round and round this forever and ever. And there are indeed neurobiologists at the moment who are utterly convinced that all our mental processes are within our brain. But there are some problems with this. One is, for example, that on occasion, seldom, but people may be born, or sometimes because of dramatic brain surgery, have to lose substantial parts of their brain. But people sometimes are born with, a hugely reduced brain, where most of the skull is full of fluid, and yet, for all intents and purposes, they're functionally normal. And it's not quite the same story, but many of us, as we go into our older age, we will develop dementia. And we hope very much that within a few years there will be drugs which will actually prevent dementia spreading. But at the moment, it's a likelihood for people more or less getting towards my age. But one of the curious things is that when you see people with dementia, especially if you're a family member, it's very unhappy time for many reasons. But oddly enough, not infrequently, sometimes a few days, sometimes a few weeks before these people die, they suddenly get all their memories back. And this is called terminal lucidity. And so effectively they become almost back to their original selves. And one thinks, well, what on earth is going on here? And it is again a hint that our consciousness is akin, as has been suggested many times in the past, to, if you like, a sort of antenna. In other words, it's a receiver, that there is, as I think one worker once suggested, a sort of mental radio. These are very imperfect analogies. But all of this, from my perspective, be it mass extinctions, missing links, extraterrestrials, animal minds, they're all pretty unconnected in a number of ways. But every one of them very encouragingly, from my perspective, is dealing with, if you like, unfinished business. This is, stuff we would like to know more about. And indeed, my views on consciousness are, I think, actually gaining a little bit of traction. But my views, of course, are based on other people's work. And correspondingly, I hope that even rather mundane things like the creativity of mass extinctions may also get a hearing in due course. But to repeat, especially with the extraterrestrials, tomorrow we receive a clear signal which, beyond any shadow of doubt, suggests that out there is a civilization. So Simon Conway Morris was wrong. There we go. Doesn't matter too much, does it? And in conclusion, it is that actually, although the received consensus is that evolution is unlike physics or chemistry, that is, it's pretty well random, it could go in any direction. In these various ways, I've tried to hint that actually there is directionality, and there is, dare I say, even an inevitability in what's going to happen in terms of the end results. But I'll come full circle, and once again, if you've not been to Kimmeridge, you should. It's a lovely village, and more importantly, you really should take a little bit of time to come into the Etches collection, because it's absolutely mind-boggling. It's superb stuff, and it's just a joy to be there. And the younger you are, the better, and the older you are, it's never too late. So thank you very much for your time.